Comparing and ordering rational numbers. Remember when we do division, numerator divided by denominator, put the decimals, then you can put those zeros. 0 will go in there 3 times, 9, do your subtraction. 1, you can bring down another 0. Oh, we can see that 3 is going to repeat. We have our answer. 4/5. 4, the numerator is inside, the denominator is outside. 5 will not go into 4. It will go into 48 times. We do our subtraction. Okay, there's the 40. Goes down to 0, so 0.8. Remember, 3/4 is 0.75, 2/3 is 0.6 repeating. That's going to be important for today. All right, we're going to compare and order positive and negative rational numbers. Remember, the smaller a rational number is as an absolute value, the smaller a negative number is as an absolute value, the smaller it actually is, or the bigger it actually is. All right, so least common denominator. A least common denominator is a denominator that two fractions would have in common. All right, so when we're comparing fractions, we don't want to be comparing 4/7 to 5/8. That's very hard to compare. We can't think in those terms, so it would be much easier if we can get a common denominator. Finding a least common denominator is a way to do that. Now, the least common multiple of two numbers is the smallest number other than 0 that both of them go into. When we look at this problem, 5/6 to 7/10, hard to compare when they're as this. But if we can make fractions the same, we can compare them easier. One way, the simplest way, maybe a little more math. Take the denominator from this side. 6/6, which is really just a fancy 1, so we're multiplying by 1, makes 42/60. 42/60 is the same thing as 7/10, just written in another way. Okay? Then we take this denominator and we multiply it by this side. 10/10. We will get 50/60. When we have denominators that are the same, we can easily compare. 50/60 or 42/60? 50/60 is more. We can put our greater than symbol showing that 5/6 is bigger. Now some of you may be going, whoa, Mr. Palm, that's extra math. You did something extra you didn't have to do. I do realize that 6 and 10 will both go into 30. So if I take 5/5, that means 25/30. If I take 3/3, that means 21/30. And again, I have the same denominator, so it's easy to compare these fractions. 25/30 is bigger, and we end up with the same result. So if you see a way you can use a smaller or least common multiple, that's fine. If you just simply use denominator over denominator to get that common fraction, that is fine. All right, so they chose to use, the denominator from the other problem to multiply on top and bottom, 50/60, 42/60, and we realize that 50/60 is bigger, so 5/6 is actually bigger. Then we have 2/3 and we have 4/5. All right, I'm going to know that 5 goes into 15, 3 goes into 15. So if I take this side by 5/5, that will get me 15 on the bottom. That will get me 10 on the top. Now this side, I do 3/3. 5/5, 3/3, both just fancy ways to write 1. So that's why we're doing the same thing to both sides. So that is 12/15. Now I've got the common denominators. I can more easily compare them. And 12/15 is larger. they decide to list out the factors. Oh, 3 goes into 15, 5 goes into 15. So how do we do that? I did that mentally. They listed them out. You don't have to list them out, but can if you want. They get 10 fifteenths. They get 12 fifteenths. They can make a comparison, and 10 fifteenths is smaller, so they put that symbol. We realize 2/3 is smaller than 4/5, and we get our answer. All right. Now 1/2 and 2/5, we can do the same thing. I see that 10 is something they will both go into. 2 and 5 will both go into 10. Only the denominators matter, so 5 over 5 here. And I get 5/10. That's just another fancy way to write 1/2. 2 over 2, and I get 4/10. That's just another fancy way to write 2/5. I can compare them. 5/10 is bigger than 4/10. I should put a greater than symbol. All right. 2 and 5. Oh, they realize that makes 10. And we go on. They get 5/10 and 4/10 just like we did. See how they're changing the fractions? Then they compare them. 5/10 is greater than 4/10, so 1/2 is greater than 2/5. Okay. Always looking for that common denominator. Now with these, that least common denominator will be good. 3 and 4 will both go into 12. So how do I get 3 to be 12? I take it times 4. If I do that to the bottom, I do it to the top, because 4 over 4 is a fancy 1. And it doesn't really change 2/3, it just changes the way it looks. You get 8/12, which is the same thing as 2/3, just in a little different look. All right, here we would do 3 over 3, because 3 times 4 gets you 12. 3 times 3 gets you 9. I have 8/12. I have 9/12. I know that 9/12 is more, so I use a less than symbol. Let's see how they attacked it. All right. They listed them out. They saw that they both went to 12. The factors of 3, the factors of 4. So how do we get there? Well, we take 2/3 times 4 over 4, get 8/12. 3/4 times 3 over 3, get 9/12. We compare those two. 9/12 is bigger, so we use a less than symbol, showing that 2/3 is less than 3/4. All right. Now, when we have problems that have the same whole number, we can even act like it's not there, because they're both 5. Well, 5 and 2/9, 5 and 2/7. So if they're both 5, we don't really need to worry about them, because those are equal, those are the same. We only have to worry about the 2/9 and the 2/7. So, hopefully you're thinking in your head, okay, I'm just going to focus on 2/9, I'm just going to focus on 2/7. And how do I go about that? Well, I know that 9 and 7 will both go into certain numbers. All right? I know that they both go into 63, or I can simply use, 7 times 7, or 7 over 7 times 2/9, and 2/7. I can take times 9 over 9. Remember, I'm just using the denominator. Just using this denominator over here. And we'll get the same one. So that would make 63. That would make 14. This would make 18. That would make 63. When we look at these, then we can see 18 over 63 is bigger, so we use a less than symbol. Say 14/63 is less than 18. We can use that up here. This is because both of these are the same. We just have to compare the fractions. All right? So let's look at and check out what they did. So that's where you're starting to use a little common sense. 5 and 5 are the same, so I just have to compare the fractions. All right? Write the fractions as decimals. Oh, they changed it. This is a new way you can do it. Let's see if we get the same answers. 2 divided by 9 is 2 repeating, so 5.2. That's another way to write that. 5 and 2/7 is 5.285741. So when we compare decimals, this is like 5.2222. This is like 5.28. The way I like to look at it is 5.2222222. That's 5 with 2 repeating. Now if I look at these, oh, they're the same. This one is bigger than that one, so I know that that gets that less than symbol to show this is greater than that. If you look at the numbers after the decimal and see which one has the bigger number, they're the same. This one has a bigger number. I know that this number is then bigger than this one. Okay, so 5 and 2/7. So you can either continue to make them fractions or we can turn them into decimals. Now when we have something like negative 0.44 and negative 2/5, you have to decide, do I want to turn this into a fraction and then get common denominators, or do I want to turn this into a decimal? My suggestion, turn the fraction into a decimal. Oh, so I know that that is 2 divided by 5. It will not go into 0. It will go into 24 times, so 0.4 negative. All right, and we're comparing it to 0.44 negative. All right, my suggestion, I like to write these 0.4 negative. Now if there's nothing here, I know I can write a 0 because 0.40 and 0.4, same thing. Negative 40, negative 44. Which one is bigger? The negative 40 is actually bigger, so we get that symbol. All right, so let's show you what they did. They changed that to 0.4. Now we compare the decimals. This one is larger because it is closer to the 0 if you think of it on a number line. All right, so we get that symbol. We have 0.1 and 1.9, or 1 divided by 9. I would again change 1/9 into a decimal. All right, let's see if that's what they do. Write 1/9 as a decimal. It is 0.1 repeating. Okay, so if we think of this number, we're going to compare it. 0.111. Oh, I'd have to fill it in. 111 is bigger than 100 if we look at that. So our 1/9 is greater. We get that greater than symbol. If you have trouble with decimals, make sure the decimals are lined up. You can write them below each other and then compare those numbers to see which one. 100 is smaller than 111. Oh, I know that that number is bigger because that's what represents it. We have the greater than symbol. We'll see that come in. Okay. We have 4 and 2/9. We have 4 and 3/5. The whole numbers are the same. So I would just worry about either turning these into common fractions, so they have common denominators, or we can turn them into decimals. They say, write the fractions as decimals. Okay. 2 divided by 9. We can go ahead and do that work. I'll do it out here. 2. I'm sorry, my board's acting up. Divided by 9. 0. So that'll go there twice. 18. I see a 2 and a 0. I'm going to get 4.2 repeating. 3/5. I know 3/5 when we're doing the division is 4.6. Because I know 3 divided by 5 is 6. I can compare these. Well, 4.6 is obviously bigger. We can put our less than symbol, which shows that's the one that the alligator's eating more of. All right, let's see what they do. Okay, 4.2 and 4.6. Hey, we did do it right. We compare those two. 4.2 is less than 4.6. So we can write our less than symbol and know we've done it correctly. Here, We have a decimal and we have a fraction. I would do that. So 4 divided by 5. And we had the negative, so don't forget that. Negative 0.8, negative 0.8. They are the same. We can write our equal marks and realize those are the same number. Okay? We compare them. They're the same, so we write our equal marks. 5/6 and 0.8. 5 divided by 6. Numerator on inside, denominator outside. We do our division. 0. So that'll go in there 8 times. 48. 2, 0. That'll go in there 3 times. That's 18. I see a 2. And if I bring this 0 down again, it's going to keep repeating. So this is 0.83 repeating. So it's like having 83 and 80. Which one's bigger? The 83. You see how I just compared the 83 to the 80? All right. And we've got those different things. So that's 0.83. They're going to give you that comparison. 0.83 is bigger than 0.8. And we put our greater than symbol. To order fractions and decimals, you can either write them all in the same form, then compare them, or place them on a number line. I would write them all in the same form. You've got all these. Look at what you've got. I see 1 fraction, decimal, decimal, decimal. Do I want to turn 3 decimals into a fraction into fractions, or 1 fraction into a decimal? I think I'm going to take the easy way. So I'm going to turn 14/4 into a decimal. 14 divided by 4. Okay. It will go in there 3 times. Oh, don't forget to bring my decimal up. 12. We do that subtraction, we get 20. 4 will go into that 5 times. This is a positive number, so 3.5. Now I have 3.5, negative 3.4, 6.0, and negative 2.5. They're all decimals. Let's figure out what to do. The numbers, we just read them, represent the percentage of change in populations for 4 states. List these in order from least to greatest. So, the smallest, negative 3.4. Okay. The next smallest would be negative 2.5. The next smallest would be 3.5. And then 6.0. We listed them from least to greatest. We changed one thing, and we were able to do this. Get them all into the same form, then we can do what we need to do. All right? They like to place them on a number line. Maybe that will help you. All right? But I think you're smart enough to not have to do that. All right? Placed on the number line. That's the furthest left. That's the furthest right. That's least to greatest. Okay. Here we are again. We have 1 fraction, a bunch of decimals, 7 halves. We can take 7 divided by 2. Numerator inside, denominator outside. Okay. It will go into 7 3 times. There's a 6. We do our subtraction. 2 will go into 10 5 times. 3.5, I wonder if they planned that out. Now we have our numbers again to compare. The negative 3.9, that is the least number. That's the smallest. All right. Then we have negative 2.2. All right. Then we have 3.5 and 3.0. 3.0 would be the next biggest number, and 3.5 would be the greatest number. Least to greatest. All right. Again, see which one do we need to change, and then we can go from there. All right, let's see how they did it. They're probably going to put it on a number line, and maybe that'll help some of you visualize it. All right, I'm hoping by now you can kind of have an idea for negatives and positives. All right, negative 3.9, negative 2.2, 3.0, and 7 halves. Least to greatest. Remember, the further left you go, the smaller. The further right you go, the bigger. Hopefully, you can have a good example with that and be successful. See you guys in a bit.